Right now, somewhere in the middle of the Atlantic, thousands of people are eating, showering, and using the bathroom. They are on a cruise ship, and not one of them is thinking about where any of it goes. By the end of this week, that single vessel will have produced 210,000 gallons of sewage, 1 million gallons of wastewater from showers and sinks, and 8 tons of solid garbage. The question nobody asks on a cruise, but everyone should, is what happens to all of it when you are floating in the middle of an ocean with no pipes connecting you to anything? The answer is more sophisticated than you would expect, and in some cases, more disturbing. First, a distinction most people have never heard of. Ships divide all water waste into 2 categories: black water and gray water. Black water is exactly what it sounds like: waste from toilets. It contains human sewage, pathogens, bacteria, and anything else passengers flush. This is the most tightly regulated substance on any vessel. Gray water is everything else: shower drains, bathroom sinks, kitchen galleys, laundry facilities. It sounds cleaner, but gray water from a cruise ship can actually contain detergents, oils, food particles, heavy metals from cleaning chemicals, and fecal bacteria from hand washing. In terms of environmental impact, gray water is often the bigger problem because it is generated in far greater volumes and historically faced far weaker regulation. A large cruise ship produces roughly 30 liters of black water per passenger per day and around 250 liters of gray water. Multiply that across 9,000 people, and you begin to understand the scale of what needs to be managed around the clock at sea with no external infrastructure. So what actually happens when you flush? On a modern vessel, sewage travels through a network of pipes to a centralized sewage treatment plant located deep in the hull. This is not a simplified version of land-based treatment. The most advanced systems on board rival municipal facilities on shore. The process works in stages. Sewage first enters a holding tank where solids settle and begin to break down. Bacteria are introduced to accelerate decomposition, the same biological process used in treatment plants on land. Compressed into a system the size of a shipping container, the liquid is then filtered, aerated, and treated with ultraviolet light or chlorine to kill remaining pathogens before it can be discharged. What comes out the other end is treated effluent, water clean enough, under international standards, to be released into the ocean. The key word there is under international standards, and those standards depend entirely on where the ship is. The global framework governing ship sewage is called MARPOL Annex 4, established by the International Maritime Organization. The rules are specific. Within 3 nautical miles of land, no discharge is permitted, regardless of treatment level. Between 3 and 12 miles, treated and disinfected sewage can be released. Beyond 12 miles, in open ocean, untreated sewage from a cargo ship, which carries a crew of perhaps 20 people, can legally be discharged directly into the sea. The reasoning is that open ocean has enough natural bacterial capacity to break it down without causing harm. For passenger ships, the rules are stricter, but the enforcement is where things get complicated. The ocean is vast. Inspectors board ships in port, not at sea. A vessel discharging illegally in international waters at 3 in the morning has almost no chance of being caught in the act. And gray water, that massive second stream of wastewater, is largely unregulated in international waters entirely. Ships can and do discharge it freely beyond 12 miles from shore. This is not hypothetical. In 1999, Princess Cruises was fined $18 million after it was discovered they had been illegally dumping waste directly into Alaskan coastal waters over multiple voyages. In 2016, Carnival Corporation paid a $40 million penalty for similar violations. These are not small operators. These are the largest cruise companies on Earth. Sewage is only part of the picture. 8 tons of solid waste per week on a large ship. Food scraps, packaging, glass, metal, plastic cannot go overboard. MARPOL Annex 5 bans the discharge of virtually all solid waste into the ocean, with plastics carrying a total prohibition on everywhere. So ships process it on board. Food waste is macerated and, in certain waters, discharged at sea in small particles. Everything else, Glass, metal, paper is either compacted and stored until port or incinerated on board. Modern ships carry industrial incinerators in their engine room sections that reduce solid waste to ash. The heat generated is sometimes used to supplement onboard power. What cannot be incinerated is stored and offloaded at port reception facilities. Every major port is required under international law to accept ship-generated waste. The logistics of offloading a week's worth of garbage from a vessel the size of a small city, turning it around and sending it back to sea within hours, is an operation most passengers never see. The next time you flush a toilet on a cruise ship, the water does not simply disappear into the ocean beneath you. It enters a treatment system more complex than most people would imagine, filtered, treated, biologically processed, and monitored before being released under a framework of international law that has been evolving for decades. The engineering is genuinely impressive. The enforcement, in the vastness of open ocean, remains the unsolved part. Next time, we are looking at the device inside every large ship that prevents it from capsizing in rough seas. A gyroscope the size of a car, spinning at thousands of revolutions per minute, quietly fighting the weight of the ocean to keep everything level. Subscribe so you don't miss it.